Yeah, good evening, sir. We can start the session.
Okay. Good evening, everybody. It's Navin joining the call. Can you guys hear me? Could you please type in the chat window if you can hear me fine? Great. Thank you, guys. Sharing the screen now. And one more time, can you quickly type in give me a yes if you are able to see the screen? Great. Thank you, guys. So today, we will revisit the linear regression. We will try to dig a little bit deep into it. We will try to look at a slightly complex scenario, slightly real-world scenario, and try to understand about multiple linear regression, guys. So before that, if you recall, so a quick review of yesterday's topics, correlations. This is an example of positive correlation when the x-axis is increasing, the y-axis, or in other words, when the x-axis is more, the y-axis is more, the values are more. So they are positively correlated. The age of children is positively correlated with heights, and here we have the temperature, which is negatively correlated with the time taken by the babies to crawl. Babies take less time to crawl when the temperature is high. That means when the temperature is high, the time taken, the y-axis value is low. When the temperature is low, which means when it is cold, babies take more time to crawl. So this is negative correlation, guys. So these are like the visual patterns in the world of data science and machine learning. And then we have briefly discussed about zero, which is neutrally correlated or no correlation, guys. Then we looked at an example. We briefly discussed an example of a class where students are getting good marks in English or also getting good marks in mathematics. And but what is the catch there? The catch is correlation does not mean causation. If you recall, causation is an impact, is a logical impact. Smoking causes lung cancer. That is going to be a high impact or a very high chance of somebody getting lung cancer if they are into smoking. And but back to the example of English class with English students and mathematics students. Just because a few students are getting high marks in English, they also got high marks in mathematics. It does not mean if we train somebody well in English, they will also get good marks in mathematics. That is not a guarantee, guys. So again, that is what is causation. There's no definite guarantee that, hey, if you do well in English, you'll get good marks in mathematics, because they are totally two different conceptual thinking subjects. So the same is with Sachin Tendulkar. If Sachin hits a century, maybe a few games, India lost. It doesn't mean that in the future, whenever Sachin will hit a century, India will lose a game. So that is what is correlation. Does not mean causation, if you recall. It lies between -1 and +1. 0 means neutrally correlated, guys. Then we briefly discussed about the regression. We discussed about some of the steps. We are yet to talk about some of these aspects in the coming up days. Linear regression is generally between two variables, quantitative variables, and quantitative is numerical data, salary and experience. What do? You draw a line, and then you're suddenly able to tell a story. You're helping the business in making decisions how much they should be able to pay for somebody with 0 years experience versus somebody going from 3 to 4, 4 to 5, and so on, guys. The line is referred as best fit line. We briefly discussed about how we come up with the steps and things like that. Everybody, can you give me a quick yes, guys, if you recall these steps? I'm just quickly going over them. Okay. And now today we'll increase the complexity and take a look at a slightly different data set. Give me one. Okay, let's come back here. So before going to the data set, let's have a quick look at what we have here. There it is. Machine learning. What is machine learning, guys? Remember, Machines learn from data. Humans learn from experience. Okay, let's take one of our folks here. Let's say take Sri Vishnu. Back to Vishnu. He's an assistant professor. But for a moment, imagine Vishnu is a kid. He touches fire. And he learns when you touch fire, your fingers will burn. Let's take another kid. Let's say, who else we have? Lakshman. Lakshman is another kid. He's a friend of Vishnu. What can Lakshman learn? Lakshman can now learn from Vishnu's experience that when you touch fire, your fingers will burn. Lakshman need not touch the fire and again learn that when you touch the fire, fingers will burn. What generally happens is humans learn from each other's experience. What is experience for humans is data for machines. Humans learn from experience, machines learn from data. What is it that is machine learning? Actually, behind the scenes, machines are doing the complex mathematics, statistics, and probability. We are learning. What's happening? Learning is happening using machines, that is machine learning. In other words, a friendly way to remember is humans learn from experience, machines learn from data. Okay? Now, in machine learning, supervised learning is one kind of machine learning. So let's see if we can simplify it, guys. Yesterday, if you recall, we took a group of students' data and we have separated the data into roughly 80% yesterday and 30%. So we visualized we had a tutor and there is a tutor. The tutor first separates the questions and answers, then he's separating the 70% of the questions or 80% of the questions and 30% of the questions. This is the first thing. Okay, then we have a student. Let's say choose this one or choose this is used, everything is used. Let's say here is a student. Here is a student and the tutor is training the student. So now what the tutor is doing is, imagine there were 100 questions. The tutor is only giving him 70 to 80% of the questions and asking the student to study. What is the student doing? The student is painting a paint. He's trying to understand the concepts. He's painting a paint in his brain. When you're trying to understand the concepts at a neurological level, you're doing some art in your brain. And now, let's say, if this student studies well, he will draw a good picture. If he understands the concepts well and things like that, what will the tutor do? The student will come back when he studies. When he studies, he will come back and tell the tutor, hey, I'm done studying. So now what the tutor will do is he is going to take the 30% of the data and he's going to give it to the student. And what is he doing? The student is using his understanding. And what is he doing? He's answering the questions. How many of them he is answering correctly versus how many of them he is not answering correctly is the final score. That is what is called accuracy. Okay, we'll talk a little bit more about the accuracy. But what is this? This is supervised learning. For the sake of simplicity, imagine something like this is going on. The tutor is actually, when he gives 70 to 80% of the questions, what he's doing is he's explaining these questions and answers to the student. So what is happening? There is some supervision happening between the tutor. And what is the student doing? The student is painting an art paint in his brain, which is art in painting in his brain. Okay? So what is the questions and answers? The questions and answers is the data. This is the complete data of 100 questions and answers. We have divided them into 70% of the questions and answers, 30% of the questions and answers. The 30% of the questions and answers we are not going to show. We are going to hide it. We're going to give it later for use it for testing. But the 70% of the questions and answers is what the tutor is explaining to the student. And now what is student? Student is the algorithm. Whatever is painting in the brain is the model. He's using the painting, which is the model, and he's going to answer the 30% of the questions. When he's given that, he's going to use that, he's going to answer that, and we will get the score. So what is happening here is the process of separating 70% and 30%. The objective of the tutor is we want the student to understand the concepts well. So that's why he's hiding some of the questions and answers so that he can test them. Okay, if he does a good job, if he gets a good score here, it is likely he will also get a good score in the following test and things like that. That is the wisdom behind it. So what is this? The process of splitting or partitioning the data is referred as supervised learning. Okay, guys, let's see. Come back here. For now, you don't have to be perfect in that, but give me a quick yes, guys, if you followed me so far, if you're able to recall this from yesterday. So today, we're going to look at a slightly more real-world data. You come here. C_startups. Let me open this file. Take a look at this file. Today we will explore what is called multiple linear regression, where we have multiple variables, guys. Okay, take a look at this. This is data. We have 50 companies data. If you go all the way down, that's about 51 rows, including the header. That's about roughly 50 rows of data. Forget about the colors. Don't worry about the colors right now. But what is this? Here is what is happening. There is a company. They are a venture capitalist company. Venture capitalist company means these are the companies with a lot of money, and they keep investing in other companies. They look for other companies and they try to understand which company is doing well. If a company is doing well, what will they do? They will try to invest in that company. Why? When that company makes profit, they will also get a good share of that profit. So they're constantly on the lookout for the companies. Everybody with me so far? Can you give me a quick yes? Okay, so now take a look at this. For a moment, we'll say, okay, we'll remove the distraction of the colors and things like that. So take a look at this. Here is the first company. So here is R&D. What is R&D? R&D is research and development. How much a company is spending on research and development is R&D, guys. Administration is how much you're spending on your chairs, on your infrastructure, and other parts of it. The administrative costs. Marketing spend is marketing, which is how much you're spending on marketing. Then you have state. State is the location of the company. Profit is the profit of the company. Pretty straightforward to understand. What are these? These are called the variables. Everybody with me? Quick yes, please. Okay, now come here. Take a look at the first company. This is US company, so we'll talk in terms of dollars, although we can refer to them as units, or you can also translate that into rupees or euros and whatever you're comfortable, guys. Okay, because there is a US based data. We'll, for the sake of discipline, we'll use the dollars as our units. This is a company which is investing $165,000 in R&D. They are investing $136,000. They're spending $136,000 in administration costs, which is infrastructure, and that is $470,000 in marketing, which is close to $500,000. And then here is New York. They're based in New York. Their profit is $192,000. Imagine if a venture capitalist firm is planning to invest in a company, out of all these things, which one do you think is the most important thing for them, guys? Which one do you think would be most important? Guys, can you hear me fine, guys? Could you give me yes or no? Are you able to hear? Okay. I'm getting some of them are saying low voice. Okay. So maybe it's at their end. Okay. So back to the question, the most important thing will be the profit. Okay. And why is the profit the most important thing? Because if the profit is more, then their share will be more. They can get they are making money out of the profit more than anything else. So profit is going to be the most important thing, guys. Okay. Now, let's say, start with R&D and take a look at this. Back to the first company. If you compare R&D with marketing, what is happening is, let's say, come here. Put this here. Compare R&D with marketing. Marketing is 3 times higher, roughly close to 3 times higher. If you compare administration to marketing, they're spending 3 times higher in marketing. And take a look at the profit. In spite of all this, how much money they spent, they only made $192,000 is the profit. Next, move to the second company, 162, same as that one, close to this one, close to this one, $500,000. But these guys are in California. They're almost making the same profit as that one. So the second company is same as this one. Come to the third one, 150,000, close to that, slightly far away from these guys. This is administration costs are low. The marketing is slightly low, but almost close to 400,000. These are based in Florida. They're still making a profit as much as that. Okay, now imagine we have to look at 50 companies like this. We're trying to understand the R&D, how much they're spending on infrastructure, marketing, state, and profit. What do you think a problem would be with this approach, guys? Okay, that's a tough question. Okay, it is not possible. I mean, it is very difficult for us to understand which company is doing well and which company is not doing well. Is one way to think of it. Still, that may not be the very appropriate answer. But let's see. Let's take a look at the same thing from another perspective. Will the profit of a company, for a profit of a company, do you think the profit of a company will depend on R&D, guys? Okay. Okay. So maybe, no, yes, all kinds of answers coming up. Good. Okay. So what is R&D, guys? R&D is research and development. When there is a lot of research and development, R&D. You take iPhone. What is happening in iPhone, guys? They are the guys who came up with this touch, the concept of touch, and they revolutionized the world. Today, everybody is trying to match to the quality of the iPhones, the touch, and things like that. What is that? That is something which is coming out of their R&D. And what is it? Apple is one of the most profitable companies of the world. Okay, so what is happening? R&D plays an important role on the profit. Okay, now come to administration. Do you think administration, how much you spend on your infrastructure and other kinds of costs related to infrastructure will have an influence on the profit, guys? Do you think companies will have? Okay, it is required amount. How much is required you spend, but don't overspend. What about the marketing, guys? Do you think the marketing will influence the profit, guys? Okay, absolutely. The more the marketing, the more the awareness, the more the products will be sold and things like that, guys. So marketing seems to be a good candidate. Do you think the location will influence the profit, guys? Okay, sometimes location also. We cannot say. Now, what do we have? We don't have one variable, two variables, but we have multiple variables. Okay, what is profit? Profit is dependent on all these factors is one way to think of it. So we can say profit is dependent variable. It can depend on all these things. So what is this? These are all the independent variables. The rest of them are independent variables. Everybody with me? Quick yes, please. Okay, so now one more time, let's come back and take a look at the R&D column. 165,000, 150,000, 140,000. Some of them are low. Some of them are 110,000 and so on. Take a look at the marketing. The companies are spending 400,000, 300,000, 300,000, 200,000 and so on. If you compare these two columns R&D, what is happening is the marketing, the companies seem to be spending 2 times or 3 times higher as much as they're spending on R&D. Okay, why do you think companies spend more on marketing or 2 times or 3 times more on marketing than R&D, guys? Why do you think? Why is it important to spend more on marketing? Awareness, okay. We just talked about that. More people will come to know, otherwise they don't know that you're selling a product and they will not buy it and your profit will not increase, sales will not happen and things like that. So more the marketing, more the sales, guys. So that is what is happening. If you take the administration also, this is close to 100 and it is similar to R&D. And what is happening? Again, if you compare this one with marketing, marketing is almost 2 times or 3 times or maybe 4 times more than how much the companies are spending. What are these? These are the patterns. It is not exactly possible for us to understand what is the pattern going on. Okay, what is it? That is where humans fail. When humans fail, what do? We bring in the machines. What is this? This is the data. We give this data to the machine, which is more precisely the machine uses the algorithm. And we'll try to use the algorithm in understanding the sum of the patterns, and we will try to understand which company is good to invest in, which company is not good to invest in, and things like that, guys. Okay, so what is that? That's like a real world problem. Let's try to see if we can simplify this, guys. Okay, so come here, back here. We'll start with Pandas. Pandas, if you recall, it is a package for data frames. NumPy is a package for arrays and matrices. Matplotlib is for visualization. sklearn is for machine learning, guys. Okay, so let's come here, start here. Again, for sake of discipline, I have imported these things yesterday, but I will import it again. Now, this is where we are telling Jupyter. We have a datasets folder, r_datasets folder. Point to this one, chdr. chdr means we are explicitly telling point to this particular folder. And if you ask it now, get cwd, there it is. Right now the Jupyter is pointing to our datasets. Everybody with me so far? Quick yes, please. Cool. Okay. Let's say come back here. Now come back here. We'll import, do some more imports. I think some of them are not needed. But here comes read CSV. What is read CSV? It will read this file, which is located in that folder, and there it is. The first one by default is taken as a header, the first row. The rest of the companies, close to 50 companies, are here. And what's happening? It is not possible. Some of the companies are not investing in R&D. Some of the companies are not investing in marketing. Some of the companies are not investing much in administration. And what is this? 50 companies is like a drop of water. What if you have 500 companies or 5,000 companies, and what we want to do is we want to understand which one is a good company, which one is not a good company, in which one we should invest, in which one we should not invest. Well, it becomes very, very difficult. It is not possible for humans or their brains to identify the patterns and try to understand which one is good versus which one is not good. In other words, humans fail. What do? Bring in the machines. Okay, so let's see what we can do here. Take a look at this. Here is R&D. Dataset is our data frame. We're going to the data frame. We're slicing it. Saying take all the rows. Take the first column, which is R&D, and there is R&D. So think this is actually a series object, but for the sake of simplicity, we will call this as a data frame with a single column. We have extracted the R&D column. Then what we'll do, we'll come here. We'll say R&D.values, and here is X. So if you say R&D.values, we are converting it to NumPy array. Why we converted it to NumPy array is we will give this data to a machine learning algorithm. Machine learning algorithms take NumPy arrays as input. They don't take data frames. So you convert the data frame into a NumPy array. We're going to call that as X. Next, come here, verify the type. If you recall, type will tell you what kind of an object. That is the ND array, n-dimensional array, or in other words, it's an array object, guys. Okay. And we talked about arrays and things like that earlier. So let's come back here now. We'll go back to the data set. Here is iLoc. We're saying give me all the rows. Column, which is a profit column. And here is the profit. This will act like a single data frame with a data frame with a single column. We'll again convert it to NumPy array. So the first step is you create a data frame, then you convert it to NumPy array. And now what we'll do, we'll visualize this one. Scroll down here. If you visualize this one, notice it comes up like this. What's happening here is, this is, again, one more time, an example of what is called positive correlation. The flow of the points is going like that. If you take any of the data points here, what's happening? On x-axis, we have R&D. On y-axis, we have profit. For these companies, the x-axis values and the y-axis values are high, which means all these companies are investing high in R&D and their profit is also high. Take a look at these companies. These companies have invested less in R&D and their profit is also low. These companies are somewhere in the middle. They have invested average in R&D and their profit is also average. So in other words, as the x-axis value is increasing, the y-axis value is also increasing. So they're kind of directly proportional. What is that? That is what we mean by positive correlation. Everybody with me, guys? Quick yes, please. Are you able to recall that from yesterday? This is called positive correlation, guys. Next, come here. We'll repeat the same process. This time we'll take administration column, which is the second column. Convert it to NumPy array. Then plot it against the profit. So what is profit? Profit is dependent variable. Profit is generally dependent variable is always plotted on y-axis. What do? We compare it with the rest of the other independent variables. That's what we are doing here. So let's say come here on this one. We put this here. And now scroll down a little bit. Forget about this warning messages for now. Don't worry much about that. And let's see what we have. Now if we come here, if our data is like this, what's happening? It is neither flowing in this direction, it is neither flowing in this direction. There's a lot of scatter. The data is scattered here. What is this? This is called neutral correlation. In other words, it doesn't look like there is a relationship between administration spend and profit. Okay, why? The data is scattered. Let's see, everybody with me, quick yes please. No relation, good, true. So that is the second variable. Next, come here, back to here. We'll repeat the process one more time. This time we will take marketing. This here, here's marketing. And let's see, that's how it looks like. Let's visualize this. Put this here. And let's see what is happening in marketing. In marketing, it appears like the flow it seems to be going in this direction, but there's a little bit of scatter going here. Little bit of scatter going here. Okay, so we can definitely say as the marketing is increasing, the profit is also increasing, because all these points they have, their marketing is high and their profit is also high. These are some companies where the marketing is low and the profit is low, and here there's a little bit of scatter going on here. So definitely there is a touch of positive correlation. Everybody agree with me? Quick yes please. There is not a strong positive correlation, but there seems to be positive correlation is what we can say. Okay, that's how we can say it, guys. Now here comes another one, which is state and profit. So let's say we'll visualize this first. So now take a look at this, guys. There is a problem here, and see if we can understand the problem. What's happening here is New York, here is California, and here is Florida. This is textual data. Until now, on our x-axis we had R&D, we had administration, we had marketing, which is numerical data. But now we have numerical data here and textual data on x-axis. Okay, we don't have numerical data. So what is this? We cannot definitely say this is positive or neutral, or is this scattered. It doesn't really give you a very good picture. This is not the right plot to do when you have textual data. We use a scatter plot when both x-axis and y-axis are numerical values. When one of them is textual data, what do? You use a box plot. Okay? So there is data frame, which is this is going to get all the rows, the state and the profit column, and you say box plot. Yeah, there is a box plot. Now let's try to understand what is a box plot, guys. Let's say come here. We may have briefly discussed this one. What is box plot telling you? The first thing it tells you is mid one, the green line. That is the mean, or more precisely the median. And what's happening here is what is happening. This is indicating if you're a Californian-based companies, on an average, the Californian-based companies are making a profit of $100,000. If you're based in Florida, you're probably close to $110,000. If you're based in New York, your average profit is also close to $110,000. In other words, whether you're based in California, Florida, or New York, there is not a lot of difference. In other words, let's do a little bit of cleanup. For the sake of simplicity, imagine this is $100,000, but instead of this green line here, let us say the green line, the box was here, somewhere over here, and let's say the green line was somewhere over here. This will indicate that is $200,000. What do we see? There is a lot of difference here. But here, in this case, there is not a lot of difference. Irrespective of the location where you're in, they're all close to $100,000 to $110,000 or $115,000. In other words, the difference is not much. Everybody with me, guys? Quick yes, please. Okay, so what is this? The word no difference is a big word in a mathematical or a statistical word. Okay, so there's a lot of hypothesis theory and things like that. I will not go into those details, but what we are observing is the state doesn't. Let us say If this green line which is here was here, for the sake of simplicity, then there is a lot of difference. There is a lot of difference means if you're based in California versus if you're based in Florida, you know your profit is changing a lot, which means the state is having an impact on profit. But since these are very, very close, okay, what do we do? We can say the state probably does not. The state is not influencing the profit. Okay, in other words, it's a neutral correlation. Everybody with me, guys. Quick as please. That's a slightly deep one. I'm increasing the complexity here. Bear with me. Now, that is the first aspect of it. In a box plot, this is called first quartile. This is the median. This is the second quartile. 50%. This is the third quartile. This is called the interquartile range. IQR. 50% of the data sits here. And these are called the outliers. Mathematically, they are greater than 3 standard deviations. Is what is an outlier, guys. We'll talk about the outliers in the coming up sessions and try to understand how to figure out. But until now, what we've been looking at is, let's say, come back to our Jupyter. We've been looking at visualizations. What do visualizations do? Visualizations tell you correlation. What is correlation? If you recall, correlation gives you direction. Okay, there is a positive correlation between profit and R&D. It doesn't look like there is any correlation with profit and admin. It looks like there is a touch of positive correlation with marketing, and it doesn't look like there is any correlation between profit and state because their profits are very close. What is this? This is the story of the data. Everybody with me, guys. Quick yes, please. Remember, visualizations give you correlation. Correlation gives you direction. What is this? This is the story of the data. But what is more important is correlation does not mean causation. What do we do? To understand causation, we use regression. What is regression? Regression is a machine learning algorithm. Okay, so let's go one step further and try to see what we can do. Back to our original data set. We're going to go back to our original data set. We're going to say, give me all the rows and remove the last column, which is a profit, and we'll put that as X. In other words, we are taking all the columns except the last column, which is profit. So here is R&D. Here is administration. Here is marketing. Here is state. These are all the independent variables. We separate the independent variables into X. So if you go back to yesterday's example, these are all the questions, is what it is. The next step, you separate the answers. It's going to be the profit, where we generally use the the terminology X and Y, or the notations is X and Y. This is going to be the profit. These are the answers in a slightly friendly way, guys. So the tutor comes in, he first separates the questions and the answers. And here is a function train test split. What is the tutor doing? Tutor now is going to take these questions and answers here. He's going to separate them into 80% and 20% size. So his objective is he's going to give 80% of the questions and the answers to the student. What is this one? From 2 objects, he's creating 4 objects. This is called unpacking. It's like, this whole thing is a gift box. You're opening the gift box, you're getting 4 gifts. What do? You unpack the gift box and you get 4 gifts. So what is this? That is a method, that is a process that we follow. So if you come down here, notice, you run this. We have X underscore train and things, so that is created. Let's say X underscore train shape 40. So totally there are 50 companies. It's like 50 questions and answers. 80% of them is 40. And similarly, Y train will be 10 and 4 columns. The 4 columns are the independent variables. Now take a look at this, guys. A little bit of object-oriented programming. We're going to go to the package sklearn, which is scikit-learn. We're going into the module called linear model, and we're going to import linear regression. Linear regression is a class. Generally, if something starts with a capital, it is a class, guys. If you recall, class is the architectural plan. Now what we are doing here is, one more time, we are creating an object of linear regression. So this is where the tutor is going to the student and is saying, buddy, get ready. And now, what is happening? We do a fit. When we do a fit, the mathematics, statistics, and probability is getting calculated. This is where the tutor is sitting with the student and is training him. He's trying to explain the concepts, and what is happening there? The student is trying to paint a paint in his brain. Okay, but what is happening? We're getting an error. It is saying, if you scroll down, sometimes these errors are not very friendly. It says it could not convert string to float. So what does that mean? If you take a look at X underscore train, What is the last column? Textual data. We perform mathematics, statistics, and probability steps of textual data. That is what it is. That one. It is saying you have textual data. You have to have only numeric data. Everybody with me? Can you give me a quick yes? Okay. So what did we do here? If we go back here, we have given 80% of the questions and 80% of the answers, and we are trying to train the student, and suddenly the student is saying, no, I cannot study the textual data. So what we'll do, come here, look at this. We will go back to our original data set. We'll remove the textual data column, which is the states column. So take all the rows, remove the last two columns, and if you now look at X, notice we have R&D, we have marketing, and we have R&D, we have administration and marketing. The state column, we removed it. We're not going to consider the state column. So now come down a little bit. What is that? This is going to be the questions, and Y will remain the same, which is a profit. In other words, we have removed one of the independent variable, which is the state, because it is textual data. We'll come back to that later. Okay, let's verify the shape. Shape will give you the number of rows and columns. So notice it should have 3 columns. 50 is the total number of companies, and 3 is the number of columns we have. We have removed one independent variable, guys. Now what we'll do the unpacking. One more time, the tutor is separating 80% and 20% of the questions and answers out of them. Create an object of linear regression. Why? This is the method. X plus y whole square is x squared plus y squared plus 2xy, right guys? So just like that, that is a method, that's a formula. This is like that. You create an object, you call it fit. When you call fit, this is where the student is studying. 80% of the questions and 80% of the answers are given to him. So what's happening? When we do this, we say we're giving the data to the algorithm. Linear regression. What is happening? It becomes a model. So the student is painting a paint in his brain. So what is the painting? The painting is art. The art is the student itself. The student itself is the painting and the art. Now what can he do? He's capable of making a prediction. Okay, what does that mean? Take a look at this. He has studied it. Now what we'll do is we'll try to test the student. So regressor is the student with the painting, with the understanding of the concepts. When we say predict, predict means you're testing. You're giving him 20% of the questions and you're saying, give me the answers. Let's see, here is y underscore pred. So what is this? This is y underscore pred. These are the answers he's predicting. For each company, if you take a look at x underscore test, this is how it looks like. For this company, they spent $66,000 in R&D and $182,000 in administration, $118,000 in marketing. And what is it? Well, we are predicting for a company which is spending this much money, their profit is going to be this much. This is a predicted answer. But what is the actual answer? The actual answer is y underscore test. So what's happening? Y underscore test is 103,000. And what did we predict? Close to 103,000. That's a good prediction. Imagine there's a cricket match tomorrow. We predicted Sachin is going to score 103 runs. And what did he do? He scored 103 runs. That's a good prediction. That's a very good prediction. Okay, our predictions should be as close as possible. Take a look at the next company's profit is 144,000. What are we doing? We're predicting 132. So what is this? It's like, you predicted he's going to score 132 runs. And what happened? He scored 144. So what is the difference? The difference is error. Okay, what is the objective? The error should be as less as possible. If the error is less, our prediction is as close to as possible to the actual score. And what is that? That's a good prediction. Everybody with me, guys? Quick yes. Okay, so like that, what is happening? These are errors. We can take a mean of all these errors. But more importantly, now what we'll do is, let's come here. Take a look at, before we calculate the error, let's go back to the regressor object, which is a machine learning algorithm object or the model object. And here is the coefficients. There is something called coefficients, which is giving you information like this, 0.77. What is this 0.77, guys? It is indicating for every 1 unit or $1 investing in R&D, it is having $0.77 on profit. Okay, what is this? That means there is an impact. That's a causation. You put $1 in R&D, your profit is increasing by $0.77. It is increasing. by 0.77. Take a look at administration, it is only 0.02. So if you put 1 rupee in administration, your profit is increasing is only by 2 paise. And you take a look at marketing, it is only 0.03. What is 0.03? If you're investing 1 rupee in marketing, you're only getting 3 paise in profit. But take a look at R&D, you invest 1 rupee in R&D, you're getting about 0.77 rupees. That's like close to a rupee or 80 paise for every 1 rupee or $1. Everybody catching that, guys? Can you give me a quick guess? The coefficients is called magnitude. That is what is describing you, the causation aspect of it. What is this? If you now come back to the data, notice how much generally companies are spending. They're spending only 1/3 of what they spend in marketing. Now you go to the business and you tell them, guys, if you reverse this, you're spending only 1/3 of this one in R&D, but it is R&D for every $1 you're spending on R&D, your profit is increasing by 0.8 units. What is that? That is a very, very useful and a very, very helpful insight. Okay, what will companies start doing it? They will start taking it seriously. They will reduce the imagine they're going to reduce the marketing spend, and imagine they're going to increase how much they're spending on R&D. What is that? That's a totally different direction in which the company is going. Everybody catching it, guys? As data scientists, you don't need to find hundreds and hundreds of insights. Just one insight like that can change the direction of the company in which they are moving. Everybody with me, guys? Quick yes, please. And what is this? This is multiple linear regression. Okay, what is happening? We are now telling not only the story of one variable, we are telling the story of multiple variables. What is this? This is called the story of the data. That is what is data science. Everybody with me? Quick yes, please. What are we doing? We are using machine learning algorithm to tell the story of the data. Okay, guys. So now, just for the sake of discipline, we'll also run the intercept. If you recall, intercept is where the behind the scenes the best fit line is being drawn. When your linear regression is drawing the best fit line, it is touching the y-axis where x-axis is 0, that is close to 42,000. That means in companies which have not invested in R&D, where the R&D is 0, roughly about $42,000 to $43,000 they're still making. Profit is roughly we can translate. That's not a very, very important thing, but a very, very important thing is this one. Suddenly your scientists are coming back and telling, guys, you're spending very less money on R&D, but it is R&D which is making the most impact on profit. Is a very, very powerful thing in a real world. If you tell that kind of insights, share that kind of information or insights or knowledge with your business, they will fall in love with you. They would like to know more. Because logically, as humans, what do we think? More the marketing, more the sales, more the profit. But here the story is reverse. Okay, what is it? It is R&D which is actually making the profit increase. Catching it, guys? Okay, let's see. So this is called multiple linear regression because we are using multiple variables. If you use only one variable, it is called simple linear regression, guys. So now I'm going to increase the complexity a little bit. Let's go a little bit more into real world and see what happens in the next step. Let's say, come back here. Imagine for the sake of simplicity, yes, I'll be sharing the data set and the code, guys. Don't worry about that. Let's say, come back here. There you go. Now, imagine, let's see who are all the guys here. Let's say, Vishnu, back to Vishnu. Vishnu is the CEO of a company, and let's say, Tarun is a data scientist who worked on this. He goes to Vishnu and he shares this kind of knowledge or insight. He tells Vishnu, hey buddy, you're spending too much on marketing, but marketing is not helping you. Your hero is R&D. That is the rock star. He's there. That's where you need to be investing more. And let's say Tarun also told Vishnu he has done this analysis using the machine learning techniques, but what did he do? He did not consider the state. But let's say for a moment Vishnu comes back to Tarun the next day and says, hey buddy, the state is important. I don't want you to ignore state, even though it is textual data. Can you do some kind of magic at your end and include the state and restate your story, retell your story to me. Everybody catching it, guys? In other words, Vishnu is coming back to a scientist, data scientist team, and saying, guys, you said in your analysis you removed the state, you said the location is not important, but based on our experience, location is very important. So we want you to analyze it, we want you to include the state and retell the story if it is going to be any different. Can you prove it again? Can you play around more, and can you come back with the stories? Imagine what they're asking. Okay, so let's see what we can do here. Come back here. Now take a look at this. I'm going to import a few classes here: array, label encoder, and one hot encoder. We'll do these imports and this is where the action begins. Can any one of you recall and tell me what kind of an object is dataset2 here, guys? What kind of an object is dataset2 here? If it starts with a bracket like square bracket, what kind of an object is it? It's a list object. Okay, list object is a tray of different cups. So notice we have pizza, burger, bread, and so on. Pizza, burger, and bread, 3 different kinds of textual data is here. Now, let's see, can you take a guess what this step is doing, guys? It's a slightly simple answer, but a slightly tough question. What is this step doing here? We're converting it to an array. You're taking a list object, you're giving it to an array, and what's happening? An array is getting created. So this is more precisely an array. You converted a data set into a list into an array is what it is. More from a discipline standpoint, guys. Okay. Now we're going to create an object of label encoder, and notice what this will do. We're going to say label encoder.fit transform. So what is label encoder? That is what we're about to see. Take a look at what happens now. Here is what it looks like. When you create an object of label encoder and you give it this array, you're getting these things. So what do you think label encoder.fit is doing, guys? Can you take a guess in a friendly way? You're converting from textual to numbers, numeric data. What do you have? When you have textual data, what you can do is you can convert them to numeric data. What do? You can use one of the techniques is label encoding. But there is another technique, a more sophisticated technique. Let's see what that is. Take a look at this. We will use what is called, this is like an array. This is like an array. We will do a reshape here for the sake of discipline. In other words, it's more like a method. And notice what is happening is we converted it into a 2-dimensional array, which is a matrix. Okay, why think of that as a manual step? That's a that's a step which is required as part of the method. Now take a look at this. We'll create an object of one hot encoder. Now what we'll do, we are going to take that matrix and we'll give it to one hot encoder. Notice what happens. It's converting it into a binary format like this. So what is 2? 2 is pizza. Then we have burger. Then we have bread. Okay, 2, 1, 0. Pizza, burger, and bread. Now this one has been converted into 0, 0, 1, which will become the pizza, 0, 1, 0, which will become the burger, 1, 0, 0, which is the bread. What did we do? This is called one hot encoding. Label encoding is simple encoding. In simple encoding, you're just converting them into 0, 1, 2s. But one hot encoding is you have converted them into this binary format. Everybody with me, guys. Quick yes, please. Okay, now let's dig a little bit deep and see what we have. In the data that we have, guys, here is our state column. This is textual data. What do? Imagine what we are going to be doing is for every column, for every state that we have, we'll create a column called. Imagine we had only New York and California, we'll create 2 columns. Why? We are going to convert them into numerical data. Wherever there's a New York, put a 1 in that column, otherwise put a 0. Wherever there's a California, put a 1 in that column. And now what you do, these are called, we just converted textual data into numerical data. These are called dummy variables. Everybody with me, quick yes please. Pardon me. Oh, sorry about that. Okay. Okay, so these are called dummy variables in a machine learning world. They are nothing but we are converting the textual data to numerical data. Now there is one more step. What do? You remove the state column because that is textual data. And if you have 2 columns, you should remove one of them. Why? That is called the mantra of dummy variables. If you have 1 column, if you have 2 variables, 1 column is enough. It is sufficient. Wherever there's a 1, it is indicating it's a New York. A 0 means it's a California. So you do not need the next one. So what is that? Always omit one variable. What is this? These are called dummy variables. Everybody with me, guys. One more time. Quick guess, please. So in our case, if we come back here, now let's come back to our data. So take a look at this. Here is X. One more time, we're going back to the original data frame. Let's run it. Here is R&D, administration, marketing, and the state, which is New York. So now that's about 50 companies. What we will do, here is Y. Y is the profit, which is the last column, which is the fifth column. We're separating them into X and Y. Now what do we do? One more time, for the sake of discipline, we'll create a label encoder. We'll one more time take a look at X. So here is X. Is X dot shape, 3 rows and 4 columns. Now what we'll do is, we'll do something like this. Go to X, this is NumPy array, we're doing a little bit of slicing and dicing. Take all the rows, 3 means 4th column. 4th column means the state column, which is a textual column. What do? You do label encoder dot fit. Fit, transform, fit are same, guys. You do label encoder dot fit, it will do its magic, which is simple encoding. Now take a look at X. Notice we have 0, 1, 2. What is the first one? The first one is New York, second one is California, the third one is Florida. So New York has become 2, California has become a 0, Florida has become a 1. This is called label encoding. Everybody with me, guys. Quick yes, please. Okay, now scroll down here, put this here, come down here. What we'll do is we will extend this, and now we will do what is called one-hot encoding. Okay, so what we will do is we will import a class called column transformer. This is how you do one-hot encoding. Is we are creating an object of column transformer. We're telling it state is a column. We're passing it an object of one-hot encoder. 3 is the location, which means we're telling the fourth one this is a default value. Okay, now here what do? You say column transformer dot fit. And now take a look at X. This one, the 4 steps here. Now take a look at this. R&D is here. Administration, marketing is here. Now notice this. This is New York. 001 is New York. This is Florida. Now this is California. 100 is California. And here is Florida 010. Everybody with me, guys. Quick yes, please. This is called one-hot encoding. What did we do? We just converted textual data into numerical data. But the mantra of dummy variables is you don't, if there are 2, 1 is enough. If there are 3, 2 are enough. If it is 00, you can say it is New York. If it is 10, you can say it is California. If it is 01, you can say it is Florida. So you can remove one column. That is a mantra. Always omit one variable. So for that, what we'll do, we'll come here. For the sake of discipline, we'll verify the number of columns. Export shape. 6 columns are there. Now what are we doing? We're saying go to X, initialize it to, go to X again, take all the rows, but the columns from 2 till the end. And once we do that, now if you do an X dot shape, it becomes 55, which means we have indirectly ignored the first column. You can ignore the first, second, or third column, any one of the columns. As you ignore the one of the columns, what have we done? We are deleting one column. Why? Because there are 3 values, 2 columns will be able to tell you which one is California, New York versus Florida. Everybody with me. Quick yes, please. 6 columns has been reduced to 5 columns, guys. Now come back here. What we'll do? Back to the tutor. We have X and Y ready. This time we have included the state because our CEO Vishnu has said, hey, he needs the CEO there, the state there, and converted it to numerical data. So back to the tutor, he's going to unpack them. Let's unpack it. That will create the 4 parts. Create an object of linear regression and fit it. Nothing will show up. What do? You predict it. You predict means you're taking the 20% of the questions or the companies and you're predicting. And now let's look at the coefficients. Now if you take a look at this, the first 2 coefficients are not really interpretable. These 2 are related to the state. They're not really interpretable. But notice it is having a negative. Negative means it is kind of an indication of a negative correlation. Back to 7.73. E minus 0 is 10 to the power of minus 1. That means 0.77. It is the story of the R&D. It is indicating for every 1 unit that you are spending in R&D, your profit is increasing by 0.77 units, which is the same. Then come to administration 3.2 multiplied by 10 to the power of minus 2 is 0.03. Administration is 0.03 units. Marketing is also 0.03 units. Okay, so now what did we do? We did not ignore the state. We have included the state. And what is it? This is the story which is developing. Okay, so that is what is multiple linear regression, guys. Okay, there are a few more advanced steps, but at this stage, what we'll do is come back here. Now, what we are doing is, when we are doing a fit, we are building a model. What is x and y? Y is dependent variable. For us, y is the profit. X1 is independent variable. When we use only one variable, that is simple linear regression, in real world, you don't have one variable, you have multiple variables. It is called multiple linear regression. But what is important is, remember, not all the variables are important. There are some variables which are not very important. Imagine Sachin. How much Sachin will score may depend on the bowling pitch, the batting pitch, or the temperature. What is that? Whether it is a bowling pitch or batting pitch or a temperature are important columns or important factors which are impacting Sachin's performance. But the phone numbers of the audience sitting in the stadium will not impact the performance of Sachin. Everybody agree with me, guys? Imagine we were given the data of the phone numbers of the audience sitting. Well, whatever your phone number, that will not impact. What should you do? You should remove it. What is that? That is what is important. That is what is called feature selection. If we include the phone numbers and we try to build a model, okay, the model is nothing but mathematical steps, a series of mathematical. It does not know. Okay, so what is it? That is called garbage in. If you give data like that, you will get a bad model. A bad model will not do a good prediction. Okay, guys. So how do you select good features? That we'll see in the coming up days. Today, I wanted you to demonstrate a touch of a slightly real-world data set, how things work in a business, and what is called multiple linear regression. Everybody with me, quick yes please. Okay guys, questions time guys, open it up for a few questions. Let me see if I can take a few of them. Give one new data point. Okay, the one new data point is nothing but, that's what we are doing here. When you say predict x underscore test is not one data point, but it's a group, it's an array of data points. You create an numpy array and then you can pass it to predict. That will give you the prediction. Fit and fit transform are doing the same thing, but they are related to different classes. Generally, machine learning algorithms, you say fit, fit, fit. Okay. Encoding and other kind of classes, you say fit transform. Two steps are happening in one. That is what is happening internally. In fit transform, it is similar to fit. Why to remove dummy variables? Because we remove one of the columns because two of them are enough to identify the three possible combinations. Okay, 1,000 companies. Okay, and where can we find? Okay, I will upload the data set also. Okay, we'll be discussing that in the coming up days, Pawan. Use of one-hot encoding. One-hot encoding is converting textual data to numerical data. As I said, we'll be uploading the code and also the data set, guys. How do we select random? No, you don't select random state. That is the data which has been given to us, or that is the data which we already have. This is a scenario where the company has data. There are some scenarios where the company does not have any data. In such cases, we need to go to the internet. We may need to manually do the web scraping and download the data. Okay. Accuracy of this model, that I'll save it for the coming up days. I don't want to discuss it today because the scope of many of the students here is in the beginning. If I right away talk about them, I will take one after them, guys, one after another one. It will be easy for the rest of them also to follow and understand. SQL is not mandatory, but it will be helpful. Whatever we discussed in slicing and dicing, those kind of techniques can be done using SQL, but slicing and dicing is super powerful compared to SQL. To collect the data, one technique is we can scrape the data. One is you can manually copy paste, you can scrape the data, you can download the zip files from internet if the data is available. You can give any random number. Yes, you can give any random state. Random state is nothing but reproducibility. Okay, we'll discuss that. Is Sql and Pandas? Yes. So whatever you are doing slicing and dicing in Pandas, we can do them using SQL-like syntax. And Pandas is, more than what SQL can do in a much more short and a compact way. You can give any random state. Yes, the random state will, as I said, will it's for reproducibility. Because it is having zero. Yes, you can remove. Because it is, you can remove the administration. Yes. sklearn is a package for machine learning. Pramavati. How can we predict the effect of state now using the first two coefficients? It's not directly interpretable. The state is not directly interpretable here. Funny. Even though it is giving us the coefficients, it's not directly interpretable. But from the correlation, we understand there is no difference. Okay, the objective here is not to interpret the state. The objective here is to demonstrate or show you how we convert the textual data to numerical data. Yes, you can draw pie charts, you can draw different kinds of charts, guys, but visualization will take a long time, and I'm putting it slightly outside so that we can focus a bit on machine learning algorithms. How can the textual data affect the accuracy? Textual, okay. If we are taking purely textual data, there are other ways of converting it to numeric data, and then we take the numeric data and give it to the algorithms to build a model. Perceptron. Perceptron is a deep learning way of doing a linear regression. Probably next week I'll be touching a little bit of the deep learning. Okay, Rajesh? Python scripting in RStudio. I think the latest version of RStudio will support Python scripting with some of the packages. If you install the packages for Python, you can do it in RStudio. Pavan. Suggest location. How can we suggest location? Here, based on our visualization, the location is not influencing the profit. Okay, so we can say location is unimportant based on this 50 companies of data. But let's say increase it to 500 companies of the data, then you may see more difference. Provide the previous GitHub link. I missed it. Okay, if any one of you, I think one of you posted the GitHub link, guys. Can you post it again, please? There you go. Previous GitHub link, okay. If influence is there, then how can we suggest location for our customer? If influence is there. Let's say one hot encoding, label encoding. Label encoding, first step is label encoding, and then you pass the label encoder object to one hot encoding. Okay, so I haven't looked at what Sai Krishna is posted here, but you can also have a look at that link. And if independent variables are dependent on each other, that is again multi-collinearity. Short answer, we cannot have a high multi-collinearity between them. You have to remove one of the variables. Justin, got your message, buddy? And pardon me. Let's see. I'll give a few more minutes for few questions, guys. Some of the techniques I'm reserving it for tomorrow and day after tomorrow. We'll touch them, and we'll so that we'll go in a particular process, guys. Okay. If textual data becomes mandatory, is such a case existing? Yes, Anil. The short answer is yes. Again, there are. What do you do? You convert the textual data into numerical data. There are different ways how we can do that. We have seen one of the ways. You can come up with your own way. There's nothing wrong. If you have a much more meaningful way, you can invent it. You can come up with your own thinking. That is what this discipline is about. In order to predict the best of all the columns, we would use what is called a p-value. That I'm reserving it for the coming up days. Sum of residual squares. Sum of squares of residual, Sri Lakshmi, is sum of squares of errors. You calculate each error, you square it and you sum it. That is called sum of squares of errors. And we generally take a mean of the square of the errors to understand the mean. There is a function we generally call. You don't have to do these things manually. Scikit-learn provides a function which will give you the mean. Prediction. Prediction is you're predicting how much a company would make with that R&D, with that administration, with that marketing. When you call the predict method, it is predicting what would be the profit. So if your prediction is showing a high profit, you can invest in that company. If your prediction is showing low profit, then you don't want to invest in that company. That is the pardon me. That is what is the insight coming out of this case study. Okay, that's multi-collinearity, Ravi. I think I explained it. If independent variables are similar on each other, or independent variables are dependent on it, then you have to remove them. That's called multi-collinearity. Okay. What you will predict with y-test. Y-test you don't predict, Rajesh. You're predicting with x-test. Whatever predicted values you're getting, you're comparing it with y-test. That is what is called the errors. The difference between them is called the errors. Regression is like a class in the package called scikit-learn. So if we get less error for the first one and more error for the second, so what we do is we take all the errors, you square them, you take a mean of it, and then your error has to be as low as possible. If you don't look at the error based on just on one or two companies, but you look at the error based on a group of companies, and you constantly try to improve the model. That's where the techniques of tuning come in. They are also slightly beyond the scope of this session, guys, because it will take a good amount of time for me to come to those concepts. Converting textual data to numerical data, that's what we have seen today. Ashok, that is the dummy variables. Take to give 0, 1, 2, 3 numbers for textual data. What factors will label encoder take to give for textual data? Jaswant, label encoding is taking your textual data and giving you the numbers called 0, 1, 2, 3. Multiple linear regression means when we are using multiple independent variables, that is what is multiple linear regression. Oh, thank you, Pawan. I appreciate it. Keep it up. Okay, guys. Did today's example or case study, is it helpful, guys? Is it giving you an idea of how the things are working? At least a high-level idea, everybody? Okay, so I don't expect you to be an expert. As I said, what will happen in real world is we need to take this concept and we need to apply it in real world. The healthcare, the telecom, you take any business, the banking business, and what will they expect? They will expect you to easily be in a stage where we are able to understand. What will happen? Generally, we have to practice a few of them. and then you will become good in these things, guys. Okay. Can you plot a graph in multiple linear regression? Yes. The short answer is yes. We can. I did not gather the code, but as my objective is slightly different here today, guys. Great. Thank you, Snehita. Thank you to all of you. So what we'll do, guys, tomorrow I will probably give you a touch of unsupervised learning, and later again we'll switch back to supervised learning, and then we'll continue our journey, guys. Okay. So give me time till maybe this weekend. I will share all these. Generally by the Friday, I will upload the code and the data sets, guys. So just be a little patient, as there is a lot of other stuff we are managing here. So just give a little bit of time on that, guys. With that, for today, I will stop it here. I think Mansa will pass on the feedback form to you. Please try to fill that and pass it on to her, guys. For today, I will stop it here. You guys all stay safe and keep learning, like guys, and we'll continue the journey tomorrow. Thank you all, guys, and we'll meet tomorrow again. Okay. Thank you, guys. Bye for now.
Thank you. I have shared the feedback form. Everyone, please fill it. Based on that, we'll consider the attendance. So please don't skip it. Thank you, everyone.